Hello, grade 11s. Welcome back to the channel. In today's lesson, we're going to be looking at Redox reactions. And without any further ado, let's just get right down to the lesson. Okay, so we have 7.1. It says consider the balanced redox reaction, and we are given copper in solid plus 2Ag plus this is the silver ion in aqueous, and then it forms the copper 2 plus ion, and then also the silver in solid. So 7.1.1 says define oxidation, right? So we know that using our oil rig, we define oxidation as the loss of electrons. So you will remember that we had this oil rig where we said that oxidation is loss of electrons and reduction is gain of electrons. So that is just a quick way to remember it. Then from here, 7.1.2 says from the balanced equation above, write down the reduction half reaction. So we know that the reduction half reaction is representing the gain of electrons, because remember, reduction is gain of electrons. So the quickest way to deal with this is to do this and then try to identify where you have oxidation taking place and where you have reduction taking place. So we know in terms of oxidation number, we say reduction is where there's a decrease in oxidation number. So reduction is the decrease in oxidation number, and oxidation is the increase in oxidation number. So looking at this, we can see that the copper here is from an oxidation number of 0. Remember, this is an atom like this. So an atom has no charge, right? It has an oxidation number of 0. And then from here, it has a charge of positive 2, which indicates that this is oxidation because it's an increase in oxidation number. But looking at Ag plus, and then it's going all the way to the Ag atom, which has a charge of 0. So from a charge of positive 1 to a charge of 0, that's a decrease in oxidation number. So that's a reduction. So in layman's term, or in simple terms, we can just say oxidation is whereby it will move from a smaller number to a bigger number, and then reduction is where it will move from a bigger number to a smaller number. So as we can see from here, now they're saying write down from the balanced equation above, write down the reduction half reaction. So since we have identified that the Ag plus is the one that is being reduced to Ag, then this is how we're going to write it. Now, mind you, if when you are writing this, you do not include the coefficients. Remember, the coefficients are only there for balancing the equation. Then our reduction half would look like this. This is Ag plus and then plus E. So you will remember that I said that this is the notation for reduction. Whenever you have electrons on the reactant side, that is indicating reduction. And then from here, we can tell what is the meaning of all this. This is telling you that Ag plus, the Ag ion with a charge of positive 1 gained an electron, and then it had a charge of 0. So from positive 1, it gained an electron, and then gaining an electron, it decreases in oxidation number. Okay, then 7.1.3 says indicate the formula of the reducing agent. So once again, you remember that we said these ones here are undergoing reduction, and these ones here are undergoing oxidation. But then let's understand, what is a reducing agent? A reducing agent, by definition, we say this is a substance that undergoes oxidation, or a substance that is being oxidized. So looking at these two substances here, remember, an agent will always be on the reactant side. So it's between the copper and the Ag plus ion. So looking at the copper is the one that is being oxidized to the copper 2 plus ion. So that means Cu here is the reducing agent. It is the substance that is being oxidized. So our answer there is Cu. Now, 7.1.4 says explanation, give an explanation for the answer in question 7.1.3 by referring to the oxidation numbers. So in terms of oxidation numbers, again, we will say why did we say copper is the reducing agent? So we mainly say that because the oxidation number increases from 0 to +2. So remember we had Cu here, and then there we have Cu2 plus. So the oxidation number increases from 0 to 2 plus, right? Then 7.2 says the following incomplete chemical equations represent a redox reaction. Then we have our equation like that. Then 7.2.1 says determine the oxidation number of chromium in this chromium, what is it? Chromium or what so not? Then we have Cr2 O7 2 minus. Now, if we are looking for the oxidation number of chromium, we know that the standards that we have is that the oxidation number for oxygen is always 2 minus, because oxygen when it ionizes like that. So that's 0, 2 minus. So now we have the oxidation number of oxygen, but we don't have the oxidation number of chromium. But how many atoms of chromium do we have here? We have 2. So this is how we'll indicate this. We'll say 2x plus 7, because we can see there's 7 oxygen ions, then multiplied by -2, which is the oxidation number for 1 oxygen, right? And then this should give us an oxidation number of -2, because remember the oxidation number that we are seeing here is the oxidation number of this whole ion, right? Then this is -2. Now calculating this is 2x, and then we have -14 and then -2. So now to calculate, we'll say this is 2x, transpose the -14 this side. So we'll end up with +12. And then if we divide both sides by 2, then our x is equals to 6. So we can now then say the oxidation number of chromium in Cr2O7 2 minus is +6, right? So that's the oxidation number of chromium in this ion. Then 7.2.2 says using information from the table of standard reduction potentials, write down the balanced net ionic reaction. And then they say clearly indicate the following: the reduction half reaction, the oxidation half reaction, and then the balanced net ionic equation. Now, this is how you want to tackle this, right? You want to use your table, because here they're saying using the information from the table of standard reduction potentials. Now, what is that table? This is the table that we are talking about here, right? So this is the table that you'll be making use of. And then let's check, what do we have? We have this here. So we must look for the equation that represents the complete equation for all this. So now looking at that one, we can see that it is where is it? It is here. So I'm using table 4a. You can use table 4a or table 4b. That is just a matter of choice, right? And then there we go, we have it like that, right? But then remember, we must identify whether that is reduction or oxidation, because remember, we do not have the same notations there. Okay, so this one would be pretty tricky to identify, right? So you're just going to leave it and identify with the other one. Remember, we know that if we have two substances like this, one must undergo reduction and the other must undergo oxidation. But with this one, it is pretty hard to read. So let's check the one that is clear to read. So Fe2 plus and then Fe3 plus, we can see there's an increase in oxidation number from 2 plus to 3 plus. That's an increase in oxidation number. So this is it's definitely undergoing oxidation. Now, if we have identified that the ion It's so funny. Iron, iron. Then is undergoing oxidation. Then that means this substance here should be undergoing reduction, right? And then how do we know that it's undergoing reduction? Remember, we just calculated the oxidation number of chromium here, and then we got Cr 6 plus, right? Then Cr6 plus to Cr3 plus, we can see this is a decrease in oxidation number. So whenever you have a substance like this, whereby you have more than one element, then they will ask you to calculate the oxidation number of one element. That means this is the element that will be referencing with whether it's undergoing reduction or oxidation. So we don't have to look at all these elements. We only need to focus on one element, which in this case is chromium. Chromium in this whole substance has an oxidation number of 6 plus, and then here it has an oxidation number of 3 plus. So this is a decrease in oxidation number, which indicates that it is undergoing reduction. Now we know in terms of writing the reduction half. So our reduction half, remember with reduction, you simply take it as it is from the table, right? Because on our table, we are given the standard reduction potentials. So this is to tell you that everything that we see here is in the reduction format. As we can see that all the electrons are on the left-hand side, right? Then we have plus 14H plus, and then plus 6 electrons to give us 2Cr3 plus, and then plus 7H2O. So yeah, remember, you have to write it exactly as it appears. Now with the oxidation half reaction, this is what we're going to do. With the oxidation half reaction, you have to note that this is in reduction format. So the oxidation half format is just the inverse of the reduction half format. So what do I mean by that? You simply take this one, make it the reactant, and take all of this to be on the product side. So that means we have Fe 2 plus, and then arrow is still a single arrow. Do not write these double arrows here. Then we have Fe3 plus E. So what is the meaning of this? It means that from an oxidation number of 2 plus to an oxidation number of 3 plus, there was a loss of an electron. So whenever you see the electrons on the product side or on the right-hand side, this indicates a loss of an electron. And then whenever you see the electrons on the reactant side, this indicate a gain of electrons, right? So now that we have the reduction half and the oxidation half, we want the net ionic reaction. So for the net ionic reaction, this is what we have to do first. Let's look at the number of electrons. From the reduction half reaction, we have 6 electrons, but in the oxidation half reaction, we only have 1 electron. That means right now we must balance the number of electrons. To balance the number of electrons, we'll check and say, what number can we multiply with here so that we have the same number of electrons as in the reduction half? We obviously have to multiply by 6, right? So now our oxidation half reaction would look like this. So this will be 6Fe, 2 plus, and then 6Fe, 3 plus, then plus 6 electrons. Now at this point, that means this is the oxidation half reaction that the oxidation half reaction that we are going to consider. At this point, we can see that the electrons, they are equal, and then these ones are appearing on the reactant side, but this one on the product side. So that means they can cancel off like that. So after canceling off, it's just a matter of writing here net ionic equation or reaction. So this will give us Cr2O72 minus. So you simply drop whatever that's on the reactant side, So we have 6Fe, 2 plus. Remember, I'm no longer considering this one. This is the one. This is my new oxide half reaction. And then also we have plus 14H plus remember the 6 is no longer there. We cancel it out. So let's check now the reducing agent. What is reducing? They want the formula of the reducing agent, but we know reducing agent is a substance that undergoes what? Oxidation. This is a substance that is being oxidized. So looking at this, which one is undergoing oxidation? We can clearly identify that it's Zn. So this is what I normally do. After doing this reduction and that, I simply write that this one is oxidation agent and this one is reducing agent. So the one that is undergoing reduction is the oxidizing agent. The one that is undergoing oxidation is the reducing agent. Then 9.1.3 says reduction half reaction. The reduction half reaction, we're going to write the one that is undergoing reduction, right? So note there's a difference between the formula of the reducing agent and when they are looking for the reduction half reaction. If they're looking for the reduction half reaction, you simply just focus on the one that is undergoing a reduction there. So now this is how we're going to write it. We'll say Fe 3 plus, and since it's reduction half, this will lose, we will gain an electron, meant to say, and then it will become Fe 2 plus, right? So from Fe 3 plus, there is a gain of an electron, and then now it goes to Fe 2 plus, just like that. Then 9.2 says, consider the redox reaction below. 9.2.1 says, determine the oxidation number of nitrogen in NO3 minus. So once again, let's solve that one. So to determine the oxidation number of nitrogen in NO3 minus. So let's look at this. The oxidation number of the whole NO3 minus ion is -1. Right. What are we looking for? We are looking for the oxidation number of nitrogen. But remember the standard or the standard oxidation number for oxygen is -2. Right. So that means we have X plus 3 times -2, and then this will give us -1. So we have X, and then -6 is equals to -1. Then this will give us X is equals to -1 plus 6. So the oxidation number for nitrogen is 5. 2.2 says balance the above chemical equation using the ion electron method. So once again, what are they looking for? The net ionic reaction. So they can say ion electron method. This should not confuse you. This still means the net ionic equation, right? So this is the net ionic equation. Then let's check. With this, we can see that the Ag all the way to Ag plus, from an oxidation number of 0 to an oxidation number of +1, this is oxidation because there's an increase in oxidation number. And then let's look at this from NO3 minus to NO2. Remember, we've already identified that the oxidation number of nitrogen here is +5. Now, if we were to calculate the oxidation number of nitrogen once again from here, we'd say this is X and then 4 multiplied by 2. And then since this is this is a compound, it has no charge, right? It has an oxidation number of okay, not, so that's 2, sorry, 2 multiplied by 2 because there are 2 so 2 multiplied by -2 because the reduction, the oxidation number of oxygen is -2 standard, and then we have 2 oxygens here. So pardon me for that. And then now it's 0 because we said this one has no charge. There's a compound. So if we were to calculate, this is X minus 4 and then equal to 0. So this is X equal to 4. Now, nitrogen here has an oxidation number 4, but nitrogen here has an oxidation number of +5. From this, we can see that this is a decrease in oxidation number, right? So what is this? Reduction, because of the decrease in oxidation number from +5 to +4, right? So we are confident with that. Now let's balance the above chemical equation using the net ionic method. So starting off, let's start off with the red half. So let's start off with the red half. So we have this for the reduction half. The one that we are dealing with is this one here, right? With the reading of 0.80. So this is NO3 and then minus plus 2H plus. So the way to identify this is simply just to look for the one that is exactly the elements that you are dealing with or the compounds that you are dealing with. Then plus E. Remember, it's reduction, so I write it the way it appears. Then plus H2O, right? So that's your reduction half. But then now let's write it the oxidation half. So for the oxidation half, we have to change the notation. Must remember that. So, but then where is it? He, He. Not seeing it here, is it? So we have Ag, but now we have to write it in this notation. So it's Ag to give us Ag plus, and then the electron is now on this side, right? So now having to write the net ionic equation, this would look like this. So the electron here and the electron here will cancel out. So we'll have NO3 minus plus Ag, and then plus 2H plus, and then to give us what? NO2 plus H2O plus Ag plus, right? Okay, so, and that's your net ionic equation, as simple as that. So this is all about canceling the electrons out. Now, question 10 says, study the reaction below. 10.1 says, define reducing agent in terms of oxidation number. So what is the reducing agent? This is how we define reducing agent. We say reducing agent is a substance that increases in oxidation number. Note how they said you must define it in terms of oxidation number. So we say this is a substance that increases in oxidation number, right? So basically, reducing agent is a substance that undergoes oxidation. But because they said in terms of oxidation number, we have to say reducing agent is a substance that increases in oxidation number. Then 10.2 says identify the reducing agent in the above reaction. Once again, this Mg to Mg2 plus, this is an increase in oxidation number. So we say it's undergoing oxidation. Then here from 0, because this is a molecule or a compound, then to I minus, it's undergoing reduction because there is a decrease in oxidation number from 0 to -1, right? Now, once you have done this, you simply say, this is the reducing agent because it's undergoing oxidation, and this is the oxidizing agent because it's undergoing reduction. Now, what are they looking for? Identify the reducing agent in the above reaction. So what is your reducing agent? It is definitely magnesium, Mg. Then 10.3 says, write down the formula of the substance that is reduced. So the substance that is undergoing reduction, right? So remember, once again, this is oxidation, and then this one here is reduction, right? So which substance is being reduced? We can see that the substance that is being reduced is I2. So 10.4 says, write down the balanced Write down the balanced equation for the oxidation half reaction. So the oxidation half reaction, once again, is this one. And then the reduction is this. So oxide and then red. So I'll just answer all these questions at once. Do the oxidation half reaction, do the reduction half reaction, and do the overall reaction. So what is overall reaction? It's still net ionic equation. So this is the net ionic equation. Okay, so now let's do that. Let's do that. Starting off with the oxide half. So starting off with the oxide half, we will say, since it changes notation, it has to be, where do we see it? This is it. But then now I have to write it in an inverse way. So this is Mg, and then this will be Mg2 plus, and then plus 2E, right? And then let's do the red half. So for the red half, what is it that we have? It's iodine. So where is iodine? Iodine. So there we go with a reading of 0.54. But then now I have to write it exactly as it appears, because remember, it's reduction half. So this will give us what? 2I, right? So you write it exactly as it appears. Now the net ionic equation, this, as we can see, the number of electrons are balanced. They're all the same in both half reactions. So that means we can just cancel them off like that. So we have Mg plus I2 to give us Mg2 plus, and then the 2I minus, right? So just like that, you have your net ionic equation, right? Awesome.